Now, before we start, let me remind you that balling is an example of the projectile motion, and that's why the concept that we are going to use in this video will be of the projectile motion only. Let's consider the case 1. From the case 1, we can see that the horizontal component of the initial velocity u is equal to minus u cos alpha, and the vertical component is equal to minus u sin alpha. Now I am using the conventional sign of convention here, according to which both the components will be negative. Or have the negative sign. Considering this point as 0, anything towards the left or below it will have negative sign. Now our next step will be to find the vertical component of the velocity right before hitting the ground. For that, we will need the first equation of motion, which is v equals to u plus at. Now, let's call the vertical component of the velocity right before hitting the ground as v1, and it is equal to, of course, since we are talking in terms of the vertical parameters, that's why we will consider this velocity, which is minus u sin alpha plus a. A in this case will be the acceleration due to gravity, and since it acts downward, it will also have the negative sign into T1. We know what T1 is. So, in the case 1, we have the vertical component of the velocity right before the ball hits the ground as minus u sin alpha, negative of u sin alpha, plus gt1. Now similarly, we will find the same quantity for the case 2. In the case 2, the horizontal component of the initial velocity is minus u, minus u cos alpha, cos beta, and the vertical component as minus u sin beta, which gives us v2, which is the vertical component of the velocity right before the ball hits the ground. as negative of minus u sine beta plus g t2, t2 being the time taken by the ball to reach the pitching point. Now we'll write these results here. V1 is equal to negative of u sine alpha plus gt1, while V2 is equal to negative of u sine beta plus gt2. Now we're going to compare the magnitude of these velocities. Let's see. We'll rub this off as we don't need it. So we have V1 equals to minus u sine alpha plus gt1, and V2 equals to minus u sine beta plus gt2. Now when we compare these two velocities, the magnitude of this velocity, we are going to ignore this negative sign. We see that u sine alpha plus gt1 is smaller than u sine beta plus gt2. How? We have u as a constant in both the expressions, g as constant in both the expression. Now we already have concluded that beta is greater than alpha, which means alpha is smaller than beta. Therefore here the alpha factor, and we also have concluded that T2 is greater than T1, which means the alpha factor and the T1 factor makes V1 smaller than V2, or V2 as greater than V1. Alright, so we have another conclusion, that V2 is greater than V1, which means